So we have a question over here. We need to calculate the potential difference between the B and D in the given circuit. So this is the circuit we have, and this is the connection between which we need to calculate the potential difference. This is BD, and there is a 2 ohm resistor here. Okay, there is a 1 volt battery connected here with a 1 ohm resistor, and there is a 2 volt battery connected here, which is further connected to 2 ohm resistor, and here we have a 1 volt battery which is connected to 1 ohm resistor, and we also have a 3 volt battery connected to 3 ohm resistor. This is C, this is A, and this is the circuit we have. Now let's start solving the question. We need to calculate the potential difference between the point B and D. So let's start calculating this. So first of all, uh, basically if we solve this section, so this becomes 1 volt battery, total 3 ohm resistance. Okay, I am making the figure something like this, that okay, this is the figure we have overall. So point B is connected here with the negative part. So this is the battery we have, because if we go like this, so this become +2 and this become -1. So this all over become -1 while going from B to D. So yeah, we have that, and 2 and 1 become 3. Why? This is 2 and this is 1. The same current is flowing, that's why this become, they are in series, so we can say this is 3 ohm resistor. We have BD here, which has 2 ohm resistor only, and let's take the lower branch into consideration. So this is 4 ohm. Okay, 3 and 1 are connected in series, so 4 ohm. And if we go this way, so this is -3 and this is +1. So overall, on going this way, we have a resistance of 4 ohm, and a battery is there, which is of -2 volt, -2 while going this side. So this is 2 volt. Okay, so this is the overall circuit. This is B and this is D, correct? Now I'll rearrange this figure, and I'll make it something like this, that there is a 3 ohm resistor and a 1 volt battery like this. Further we have a 4 ohm resistor, 2 volt battery, 4 ohm resistor and a 2 volt battery like this. Okay, and further we have a branch like this, which is BD, uh, connected to BD point. This is 2 ohm, has 2 ohm resistance. This is point D, this is point B. Okay, so no, this is point B and this is point D we have. Now let's start solving this question. Now we have seen that this is the form of uh, the polarity of the batteries are same. So we'll use the formula E1R2 plus E2R1 upon R1 plus R2. That's the formula we're going to apply for calculating the equivalent. What is E1? That is 1. 1 times the 4 plus 2 times the 3 divided by 4 plus 3, 7. So this become 6 and 4, 10 by 7 volt. That is the equivalent we are getting right now. Okay. And what is small r equivalent? This is the r equivalent of this circuit only. So that becomes 3 times 4 by 3 plus 4, 7. 4 3s are 12 by 7 ohm. For the entire circuit, now the circuit seems something like this, that there's a battery which is something like this. It is of how much? 10 by 7 volt, connected to a 12 by 7 ohm resistor, and connected to a 2 ohm resistor. So now this is point D, this is point B. Okay, Our target is just to calculate the potential difference between across this. So first of all, I'm calculating the capital R equivalent of this entire circuit, that is 12 by 7 plus 2. So that will be 12 plus 14 by 7. So the R equivalent of entire circuit is coming out to be how much? So 26 by 7 ohm. Okay, 26 by 7 ohm, and E equivalent is coming out to be 10 by 7 volt. Okay, so E is equal to I into R, which is 26 by 7. 7 cancel out. We are getting I as 10 by 26. 2 5s are 13 ampere. So I is coming out to be 5 by 13 ampere. This is the value of current we are getting right now. That means there is a current I flowing through this like this. So what is the voltage difference across the this BD? So this is I into R. I is we have just calculated 5 by 13 times R is 2. So this is coming out to be 10 by 13 volt. Okay, you can also divide it, and otherwise I leave it up to here. Hope this answered your question. Thank you very much.